Today I discuss one important problem related to linear algebra. Obviously this problem is that means consequent problem of eigenvalues and eigenfunction and characteristics polynomial related problem. Now we write this problem now. Obviously this problem is one of the famous book calculus Tom Apostol calculus books problem. Okay, we write now this problem. Given an n cross n matrix A with real entries square equal to minus I. Okay, prove the following statement. Prove the following statements about A. First, A be non-singular. Second, n is even. Third, A has no real eigenvalues. Fourth, dA equal to 1. We have to prove this consequent problem. Now first to start about A be non-singular. Okay, so first we have to show that A be non-singular. That is what we have to do. We do that data not equal to 0. Then this problem is done. Now we see that given that what is given here, just a square equal to minus I. This implies that a square equal to minus I. This implies that so simply we take in date of a square equal to date of minus I. Okay, then what happened? Then we know about that date of AB equal to date A and date B. That means date A multiplied by date A. Okay, equal to here minus 1 whole to the power n date of I. Why? Because A is an n cross n matrix. Okay, then what we do, we write here now date A whole square equal to here minus 1 whole to the power n, and obviously we know about that date I equal to 1. Then this gives what? This gives, that means we erase our portion and going to further discussion of that. Then this gives date A whole square equal to minus 1 whole to the power n, obviously not equal to 0. This implies that date A not equal to 0. This implies that A be non-singular. Not a problem at all. We also do this proof of first question. Okay, we're going to next questions. That means this question is n. Then what we have to prove? We have to prove n be even. How we prove this? We just write this one. We have to show that n be even. Okay, just easily we done it. We know about from first one that date A equal to minus 1 whole to the power n. We know about that date A square obviously greater than equal to 0. Obviously greater than equal to 0. Why? Because date A is a real, that means date A is a real valued function. Obviously date A gives some real number, and real number square obviously greater than equal to 0. Okay, and here we know about that date A not equal to 0, so date A square obviously greater than 0. Here we write about that date A be a real valued function. Okay, and here we write that since date A not equal to 0. Okay, not a problem at all. Then what we have to do, we have done that here. This implies that minus 1 whole to the power n greater than 0. This implies that n must be even. Okay, not a problem at all. We prove this one too easily. This one is right, and all these, that means steps are clearly true, I think. Then we're going to further discussion of that questions. This one is, that means number 3, or we mark as C. Okay, this questions given that A has no real eigenvalues. That means we have to show that, we have to prove that A has no real eigenvalues. What is given here? Here given that A square, given that A square equal to minus I. Okay, then this implies what? This implies that A square plus I equal to 0. Now we write about that the characteristics equation be n square plus 1 equal to 0, then m equal to plus minus I, then the eigenvalues of AB equal to plus minus I. That means this gives that A has no real eigenvalues. This implies that A has no real eigenvalues. Okay, next one, date A equal to 1. How we prove this one? We erase that portion and going to further discussion of that question. We mark as D. Date A equal to 1. Okay, how we prove it? Marked as, we have to show that date A equal to 1. Okay, so how we show this? Obviously we know about that in here the eigenvalues of A, B plus minus I. But how many times this I and minus I is, that means repeated, we don't know. Okay, A, B and n cross n matrix, so I and minus I, how many times repeated we not know. And obviously this one is we known about it, A square equal to 1. Okay, in previous problem we also find that A square equal to 1. So how we do here, we known about another further theorem related to this eigenvalues is, that means if I be an eigenvalue, then minus I obviously in eigenvalue in conjugate pair. Okay, that means if I present, then minus I also present. If I present p times, then minus I obviously present p times. Okay, so obviously product of eigenvalues must be I multiplied by minus I. If p times, then this one is repeated p times. then this one is minus I square equal to plus 1. Okay, and we know about that det A equal to product of these eigenvalues equal to plus 1. Understand or not? I think all are understand this problem. This one obviously one important problem related to linear algebra, basically related to eigenvalues and eigenfunctions. So we do it now. If anyone have any problem in this related questions, see also, that means raise a questions in this comment box, and obviously if like and if want to get this type of questions, subscribe my channel. So today I stop here.